So good evening everyone and welcome to this lecture. And thank God we are done with done with rotation and we
Rotation.
have now moved ahead. Normally the next topic that I do after electro in normal flow would be SHM, but here I will do SHM after this. Gravitation is a better way because it just relates to what we were doing in the previous section, because now we'll have that spheres and all those things again coming, so you can easily relate them probably. So we'll do gravitation, then we'll move on to SHM and the because once SHM is done, we'll move on to waves, so that you can just relate SHM with waves. And then after electro we will do ray optics and wave optics. So when you do wave optics, it will be a revision of your entire waves. So this way your waves will be revised at that point in time. So everything would be covered in that manner. Gravitation would be revised when we do electro,
By
so that will be the
electrostatics, yes.
revision of gravitation. So that is how I have planned it, so that we can do at least twice one things which are scoring, and gravitation is one of those scoring topics in which if a question comes, you should be able to do it. What is the first heading? Now, as soon as we think about the term gravitation, what is the first thought that comes to your mind? The first thought that should come to your mind is the Newton's laws of gravitation. Yes or no? So
Yes.
without much ado, let us first write the heading Newton's universal law, Newton's law of gravitation. Let us just start with this and without wasting any more time. Now, what is this Newton laws of gravitation? We have all seen that if you have two bodies of mass m1 and m2 separated by a distance of r,
R.
they will attract each other. That
Yes, sir.
attractive force is known as the force of gravitation or gravitational force. Everyone understands this, right? Now
Yes,
remember,
sir.
this gravitational force is always attractive in nature, and it acts along the line joining the two charges. I'm saying charges because I'm doing electrostatics, two masses, and it will be always attractive in nature, and the value of this electrostatic force is given by
G M1 M2 by R square.
G m1 m2 by r square, where G is a constant which is known as the universal gravitational constant. That's it. That is what you need to remember. Now this force is a vector quantity. This will only give you the magnitude of force, and hence you can call this equation as the scalar equation of force, because it will only give you the magnitude of force. How will you get the direction of force? To find the direction of force, the direction of force is along the line joining the two masses. So you have to join the two masses, and then you will have to find the force, and it would be attractive, so it will be towards each other. So that way you can find out the direction of force. You can very well see the direction of this force on 1 due to 2, F12, and this force on 2 due to 1, it is equal and opposite. Action and reaction, we all know what is action, what is reaction. Yes or
Yes,
no?
sir. Yes, sir.
Okay, now this is the scalar form of the formula. I'm not going to give you the vector form because it is of no use. If you want, you can just write the vector form. Very hardly you are going to use it. Very hardly you are going to use it. So, and the form is given. The form is also given in the round. So let us forget about it. There is no point of just confusing you with this vector form. Yeah. Okay. It is along the line joining the two masses. Vector form is not required. Now you must remember some important points about this force. So we'll just note them down because these forms are going to come in your chapter on gravitation on electrostatics as well. So remember, the first point is it forms an action reaction pair. Everyone knows it. Yes or no?
Yes, sir.
Both the forces will be equal and opposite. Then the second one is it always acts along the line joining the two masses. So therefore it is known as, some people call it, or we call it, the central force. Now remember, a very important factor, that it does not depend on the medium, because in electrostatic force, this electrostatic force depends on the medium, and therefore this is a difference between electrostatic force and gravitational force. There are two differences. Gravitational force does not depend on medium. Electrostatic force depends on medium. Electrostatic force can be attractive as well as repulsive. Gravitational force is only
It's
attractive.
only
So these are the
attractive. Yes,
differences
sir.
that you must remember. Otherwise everything remains same. Gravitational force between two bodies does not depend on the presence of third body, and hence you can use something known as the principle of superposition. What do you mean by principle of superposition? If you have more than one force acting on a body, the net force acting on the body will be the vector sum of all those forces. You must have heard about this, yes or no?
Yes, sir.
Principle of superposition, you must know about it. And this principle of superposition comes because of gravitational force between two particles does not depend on the presence of any other body. So if I am a body creating gravitational force on this mass, another mass is there or not, it does not make any difference. Therefore, you have this principle of superposition. Everyone knows this principle of superposition, yes or no?
Yes, sir.
Everyone? Okay. Now, remember, when we have read this formula of gravitational force between two bodies, remember, these two bodies are taken as point masses. This is the gravitational force between two point masses.
Yes, sir.
Or if it is a gravitational force between two bodies, then the distance between these two bodies have to be very large compared to the dimensions of these bodies. Otherwise, this formula is not valid. So remember, this formula is valid
Point mass.
only for point masses that can be treated as points. This is not a universal formula. This is a formula which is valid only if bodies, two bodies are taken as point masses. We understand this, yes or no?
Yes, sir.
Okay. Now you have a very simple question, and we will start with this question. This is question number 1. Four bodies placed at the vertices of a square. You have to find the gravitational force on each of the bodies. You can understand both gravitational force on each body will be same. You can just take any body. Let me take this body. You have to find the gravitational force on this body of mass m. You can do this, yes or no?
Yes, sir. We will
So I'll
do.
give you 2 minutes for you to do this. Yes,
Sir,
anyone with any answer?
4gm square by a square, sir.
4gm square by square. How did you get it? How did you get it? How did you get it? I'll give you 1 more minute to do it.
Okay, sir.
Think again. Shall I help you?
No, sir, we are doing.
Okay. If you can do the first question on your own, that means you can move ahead with more difficult problems.
Sir,
Yes, beta.
a cube by 3m, sir.
Okay, I think I must step in and do it. Something is not right. How are you supposed to do this? Now we have to find out the force. Three bodies are going to exert force on this. This is the green body. Green body exerts force in this direction.
Yes, sir.
This is the pink body. Pink body exerts force in this direction. Yes or no?
Yes, sir.
The masses of both the bodies are same. The distance of both the bodies are same. So forces will be same. Yes or no?
Yes, sir.
Now remember JEE is, and this F will be equal to G M
M
square by
square
A
by
square.
a
Yes or no?
square. Yes,
Now
sir.
remember JEE main or JEE advanced, even 80% is the speed. It's a test of your speed. If you can do it faster. F and F, 2F like this. So what will be the resultant? What will be the resultant? The resultant will be going along this direction. Yes or no?
Yes, sir.
And that will be equal to F root 2. Yes or no?
Yes, sir.
This will be F root 2. Okay. Now apart from this F root 2, this blue mass will also exert a force on this. Yes or no?
Yes, sir.
The direction of this force will be like this. Yes or no? If I call this force as F dash, what is the value of this F dash? It will be G into M
M
square
square.
divided by root 2A. Yes or no?
Yes, sir.
Both these forces are in the same direction. You can now add them. So what is the net force? F net will be G M square by A square times root 2,
Root
which is
2.
the resultant of these two F, plus G M square by
By
root 2A.
a.
This is your answer.
Yes, sir.
Do we understand this?
Yes, sir.
Oh, sorry. I made a mistake. It should be root 2A square, no? So it would be, sorry,
It is
mistake,
2a.
genuine mistake, 2A square. Do we understand this? Yes or no? How this is done? Okay. Okay. Now let me give you this question. It's not a direct question of finding out the force, but it is an indirect question. And these are the type of questions. You can do this question of this type. No, yes or no?
Yes, sir.
This is the next question. Two particles of equal mass m each move in a circle of radius r under the action of gravitational attraction. Find out the speed of each particle. I'll give you 2 minutes to do this. Are we doing the problem, bacha? Everyone
We
has
are
disappeared.
doing, sir.
Okay. I thought that we have disappeared. Is it such a difficult problem?
No, sir.
Then I thought it's a difficult one, looking at your faces. You got 2 minutes to do this, else I will do it. Simple question. This is a revision. Remember, this is physics. Nothing finishes. Rotation is finished, but see, rotation has come in a different way. This is not rotation, this is circular motion though. But it has again come in some way. I'll give you 1 more minute to do it. Else I will step in.
ఎందుకు ఏం కాదు వెళ్ళు
It looks like I need to step in. Such a difficult problem this is.
1 minute, sir.
Okay, I'll give you 1 minute.
అబ్బా మైనస్ జిఎం బై ఆర్ స్క్వేర్ చెప్పా మైనస్ జిఎం స్క్వేర్ బై ఆర్ చెప్పండి అబ్బా ఎప్పుడు నేను చెప్పను సార్ ఇస్ ఇట్ మైనస్ జిఎం స్క్వేర్ బై ఆర్ ఐ గెస్ ఇట్స్ రాంగ్
Minus, what does minus mean? First of all, you have to tell me the meaning of minus. If you tell me the meaning of minus, then only I will understand anything. If you don't tell me the meaning of minus, that means I will not understand anything. What has been asked in the question? Speed of this
speed
particle.
of the particle.
Have you ever heard negative speed? If you have heard about negative speed, then you give me your Valuable suggestion. If you don't know negative speed, then there is no point of talking. Shall I do it? Okay, it seems enough time has been given. So you just have to draw a very simple diagram of two particles moving in a circular track. This is the easiest diagram that you can draw.
We draw it. Yes.
That is the easiest diagram you can draw. If you draw the free body diagram, someone has to give it the centripetal force. Who will give this particle or that particle the centripetal force? The gravitational force would be the centripetal force. What is the gravitational force between these two particles? G m
GM
square
square
by
by
2a square, that means 4a square. That must give it the centripetal force. How much is the centripetal force? M v square by r. R is a.
okay.
That's it. That would be your answer, my dear friends. Should it take rocket science for doing this? It's very simple. 4r square. This is r square. You can just find out the v. Yes or no? No, yes.
Yes, sir.
It was so simple. See? Do we understand this?
Yes, sir.
Well, that was two particles. This is three particles. Now remember, whatever question we are doing here, the same question could be made in electrostatics. The only thing is here there are two masses, there will be two charges. But they cannot be both positive charges. So one would be positive, another would be negative. Same question. Now here we have three charges. Three particles each of mass m are situated at the vertices of an equilateral triangle of side A. The only force acting on the particle and mutual gravitational force it is desired that each particle moves in a circle while maintaining their original separation and determine the initial velocity that will be given to each particle to and the time period of circular motion. Remember, this is physics, nothing ends. Everything is related to each other. This is the next question. And I hope, I hope, I hope, I hope, I hope, I hope you would be able to solve this one. Yes or no? No, yes.
Yes, sir.
2 minutes you have.
Yes, sir. అమ్మ మేడం ఒక ఈక్విలేటరల్ ట్రయాంగిల్ దాని వర్సెస్ వస్తుంది ఏ ఏ దాని తర్వాత దట్ షుడ్ బి that should be going to this particle and that time is the circle.
Yes, bacha. Any hope? Or shall I do the needful?
1 minute.
I always have 1 minute for you guys. I never say no to 1 minute.
Sir, it's root 3 gm square by a square.
Huh? I have an answer. Well done. I am impressed. I am happy. I have an answer and let me check. What is the velocity given? Yes, what is the answer that you are getting?
Root 3 gm square by a square.
Root 3 gm square by a square. Oh, that I'm afraid is not correct. This is more a question of maths than physics. Shall I do it or you want me to do it? Shall I do it? Huh? Remember, this is a pretty simple,
Sir, we will do
straightforward
it as
question.
homework, sir.
Yes, beta?
We will do it as homework.
You will do it as homework. No, let me do it. I don't want to leave this question as homework because same question can come and tomorrow I forget. So I can't take the risk. This is the diagram that is drawn here. And as you can see, the center C is here and you can find out the net forces. Yes or no? You can
Yes, sir.
Both of these forces are going to be same. Yes or no?
Yes, sir.
And any force F, if I call it as F, this F will be what? It will be equal to G
G
M square by A
by
square.
a
Yes or
square.
no?
Yes, sir.
And these two forces are at an angle of 60 degrees. So you can find out the net force. Yes or no? So
Yes.
this F net will be equal to under root of F square plus F square. Remember JEE 2 times F into F
F
cos of 60.
cos 60. Yes.
Remember JEE is the test of your speed. So I'm not using vectors and this will get cancelled and cos theta will get added up. You can also do it that way. Do you understand what I'm saying here? I
Yes.
can resolve this force into two components, one along this, one along this. I can resolve this force into two components, one along this and one along this. The horizontal component will cancel and the vertical component will get added up. The answer is still same, 2F cos 30. Okay, do we understand this? Or this is going above our head saying bye bye?
We got it, sir.
So now you can write the net force as root 3 G M square by A square. We got this, yes or no?
Yes, sir. We got that.
And what? That must be equal to M V square by R. R is not A, my dear friend. R is not A. This is maths. This is A, my dear friend. This is A. And this is your R, radius R. This is your R. So you have to find out this R using A. This is simple maths. What is the value of R in terms of A? Huh? No one knows it. No one knows it. This is simple. Fifth, sixth standard geometry. You drop a perpendicular, it will bisect the chord. This is A by 2. This is 30 degrees. How many things you know? So this R will come as how much?
A by 2 square.
A by root 3. It will come as A by root 3. So you just put the value there and you will get the answer for V. How much is V? I think V is coming as under root of Gm by A. Once you know the value of V, you can find out the time period, you can find out omega. Omega is, time period is 2 pi by omega. Omega is V by R. You can find it out from this simple concept. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now, this is one question which has come many times in many exams. So, this question also comes in electrostatics. So, you can do one of this type so that, and you remember the result. This is valid in gravitation, it is valid in electrostatics, and that is the question. You have done the previous one, yes or no?
Yes, sir.
This is the next one, question number 4. You have a body of mass capital M. It has to be divided into two parts such that the gravitational force between them has to be maximum. What should be the ratio of the two parts? In what ratio should I divide it? Or what is the ratio of the part divided by the total mass? Doesn't make any difference. It's the same question asked in different ways. In what ratio should I divide it? Give you 2 minutes to do this. As you can see, this question can be asked in many ways in many exams. Remember, in what ratio it has to be divided? The ratio is 1 is to 1. Make it half. Ratio is 1 is to 1. So if you have 1 kg mass, half kg, the ratio is 1 is to 1. Do we understand this?
Yes, sir. Yes, sir.
And how do you get this? I will just show you this small thing. You just assume that it is divided in the ratio 1 is x, 1 is 1 minus x. You just find out the gravitational force. This is the question. And this is the solution. You don't have to remember the solution. You just have to remember that the ratio is 1 is to 1. Make it half. For gravitational force, or for that matter electrostatic force, to be maximum, the ratio of division has to be 1 is to 1. Should not forget this, no matter
Yes,
what
sir.
happens. Do we understand this? There's some
Yes.
things that you will have to remember. You cannot forget them. Remember, whatever questions we are doing for gravitation, the same question I may not do for electrostatic, because same questions are repeated. The only difference is here the gravitational force is always attractive. There it will be attractive as well as repulsive. So
Repulsive.
to make it attractive, I have to take one charge as positive and other as negative. Otherwise, the question remains same. Do we understand this?
Yes, sir.
This is the next one. This is the next one. Two stationary particles of mass m1 and m2 are at a distance d apart. The third particle lying on the line joining the particle experiences no gravitational force. What is the distance of this particle from m1? You have 2 minutes to do this. Same question could be made in in electrostatics. There could be two positive charges or two negative charges. Doesn't matter. Shall I do it?
1 minute, sir. క్వశ్చన్ వాళ్ళు రాసుకుంటారు. ఏంటి రాసారా మీరు? లాస్ట్ లో ఎవ్వనే ఉంటున్నారు.
As a hint, I can put this diagram. Obviously, it has to be somewhere in between.
Yes, sir. So, ఇప్పుడు G gravitational process. What is the distance of the particle from N1 to N? అది కనుక్కోవాలా R కనుక్కోవాలి. అది
Yes.
గ్రావిటేషనల్ రిజల్ట్ నుంచి
Shall I do it? This is the pink charge. This pink charge will attract it in this direction.
Smaller. Yes, sir.
This is the green charge. This green charge will attract this in this direction.
Yes, sir.
Let me call this force as F2. And let me call this force as F1.
F1.
For equilibrium, for it to remain at rest, no gravitational force, F1 should be equal to F2. What is the value of F1? G M1 into M divided by R square. What is the value of F2? G
M2
M2
into
M
M by D
upon R
R
minus
minus
D
D
whole square. They must be same. That means what? G M1 M upon R square shall be equal to G M2 M upon R minus D whole square. M and M cancel, G and G cancel. You will get a relation between R and D minus R. From there you can find out the value of R. What is the value of R coming? Not able to solve this?
No, sir, no, sir, we are doing.
Oh, I have written R minus D square. Sorry, it should be D minus R square.
R square. Yes, sir.
I should not write it wrongly. Even if it is under the root, I should not write it wrongly. Yes, what is the value of R? T times root over M1 upon root over M2 plus root over M1. This is the value that you are going to get. And remember this question may come in electrostatics. Instead of M1, M2, it will be Q1, Q2. The same answer will come no matter how many times it comes. Do we understand this?
Yes, sir.
Then this last question.
Done, sir.
Done, sir? Then this last question. Question number 6. You can call this mass as m1, you can call this mass as m2, and you can call this distance as r, because not going to evaluate you on your calculation skills. I am going to evaluate you on the basis of your math skill. Two particles of mass m1 and m2 are separated by a distance of r. Assume that the only force acting on the particles are mutual gravitation. There is no earth, there is no gravity of earth. What is the initial acceleration of the heavier particle? Let us say m2 is heavier than m1. What will be the acceleration of the heavier particle, which my difference is m2? And the answer is, you find the force between them will be same, g m1 m2 by r square. You have to find out the acceleration of the particle m2. What will be the acceleration of the particle of mass m2? The force is g m1 m2 by r square, force divided by mass. So it will be equal to g m1 by r square. That will be the acceleration of the particle 2. If someone would have asked what is the acceleration of the particle 1, it would be g
M2
m2
by R square.
by r square. So remember these small things. We have started the chapter on gravitation. We have just now dealt with gravitational force between point masses. In the next class, we'll go ahead and see gravitational force due to other bodies as well. We'll restrict ourselves to very few bodies, because the rest of the bodies will become in electrostatics. The concept is same. There is no point of doing the same question. So we'll restrict ourselves to the sort of question that are more likely to come on the bodies which are more likely to come, because in electrostatics we will be dealing with the same bodies. Again, the only difference is q1 and m1, and instead of g it will be k, 1 by 4 pi epsilon, not nothing else. So we will continue our discussion in the next class. I hope you have enjoyed this class, and see you in the next class. Take care. God bless all of you. Bye bye.
Thank you, sir.
Bye beta.
Bye, sir.